This is the final week. The assignment you have to complete is both the practical test and the fourth and final test. The practice test closes Friday and the final class test closes on Saturday. In chapter 12, we turn to methods for analyzing interval and ratio measures to explain variation in the dependent variable. First, the Pearson correlation coefficient, denoted by the small r, measures the relationship between interval and ratio measures. The range of the Pearson correlation is +1 to -1, where +1 and -1 are perfect relationships. You'll find a chart on page 238 which gives you guidance on interpreting the Pearson correlation. Next, chapter 12 on pages 239 and 240 discusses scatter plots, which is a visual expression of the relationship between two interval or ratio variables. The scatter plot depicts each case on a grid. The dependent is on the vertical axis and the independent on the horizontal axis. What we are looking for on a scatter plot is a pattern, and we use a regression line to determine the direction of the relationship between the dependent and independent variables. The closer the data points are to the regression line, the stronger the relationship between the dependent and independent. A perfect relationship is where all the points line up on the regression line. A regression line is also referred to as a prediction line, where knowing the independent allows us to predict the dependent. The distance between data points and the regression line illustrates the amount of error involved in predicting a perfect relationship. This difference between an actual value for a case and the predicted value is referred to as a residual. All of the lines in aggregate on a scatter plot tells us how much error there is in predicting the values of the cases for the dependent variable by knowing the values of the independent variable. To use the Pearson correlation coefficient as a PRE measure of association, we have to square the value of r, the small r, and multiply it by 100 to obtain the percentage of variation in the dependent as explained by the independent. We can also control for other variables in correlation. If the control variable is nominal or ordinal, we compute separate correlation coefficients for each category of the control variable. Then we compare them to the original correlation coefficient to see if they are the same or noticeably different. The process is very similar to the one we discussed in chapter 11. However, we can control for more than one variable at the same time. But using two or more means that the number of cases in each could be so low to make it irrelevant. When the control variable is interval or ratio, then we use what's called partial correlation. But this technique is only mentioned in the text and not something you have to worry about in this course. Finally, chapter 12 ends with an explanation of multiple regression, where more than one independent is used to explain the dependent. There are two main questions to be answered using multiple regression. First, how well does the independent explain the dependent? And second, what impact does a particular independent have on the dependent when controlling for the effects of the other independents? The first question is answered by the square of the multiple correlation coefficient to give it a PRE interpretation. The square of the multiple correlation coefficient is represented by the symbol r squared. However, the multiple correlation coefficient has no direction because there's more than one independent involved in the equation. In other words, while one independent may be positively related to the dependent, another could be negatively related. To get the percentage explanation of the variation for an r squared value, you simply have to multiply it by 100. The second question is answered by the beta coefficients, which are standardized partial regression coefficients. Standardized because beta coefficients tell us how many standard deviations of change in the dependent are produced by one standard deviation of change in the independent. By standardizing, we can compare the independents to see which are more important than others. In other words, the higher the beta coefficient for an independent, the more important it is in explaining variation in the dependent. As a last word, regression can be used with nominal and ordinal data.